We present a neural relighting and expression transfer technique to transfer the facial expressions from a source performer to a portrait video of a target performer, while enabling dynamic relighting. Existing style scan-based techniques can produce photorealistic portraits with changing facial attributes, but it suffers from unrealistic facial interpolation, especially for the reenactment task. Recent neural rendering approaches managed to transfer the facial expressions from the source to the target person. However, these techniques have been limited to pre-baked illuminations. Image-based relighting techniques can synthesize new lighting conditions, but are by far only applicable to the same target. We instead present a neural rendering framework to transfer facial expressions with arbitrary backgrounds and lighting conditions. Firstly, our portrait parsing module aims to generate a set of conditioning feature maps consisting of projected normalized coordinate code map and a rendered face image of 3D face model. Our reflectance field generation module employs a conditioning rendering to video translation framework, which adopts a multi-frame multitask learning framework. The final trained network supports simultaneous relighting and expression transfer at high realism. To recover the 4D reflectance fields of dynamic portrait, we build up a light stage with 96 fully programmable LEDs and a stationary 4K ultra high-speed phantom capture camera at 1000 fps. We demonstrate our technique in a variety of video rewrite applications. Given a reference sequence of the source actor, we extract its corresponding facial pose and expressions to recover the reflectance field of the target performer under the new background and lighting conditions. With our normalization technique, we can transfer the mouth motion reasonably, which allows the target character to match the audio while speaking.
I have a dream that one day this nation will rise up and live all its true meaning of its creed. We hold this truth to be self-evident, that all men are created equal.
Our technique is applicable in various virtual and augmented reality applications. In virtual conferencing, a user can change his or her appearance with new backgrounds. For example, our technique managed to correct the pose of the user, even if the source video is not captured up front. Recall, our neural video portrait technique can be alternatively viewed as mapping from the facial parameters to the reflectance field, where the use of deep networks make the mapping differentiable. We hence can interpolate the expression parameters to equivalently interpolate on lighting. Recall that we obtain a 96 light sources OL80 dataset at an effective frame rate of 25 fps. Via expression interpolation, we can synthesize an OL80 at 1000 fps, which in reality would require using a camera with a frame rate of 100,000 fps, prohibitively high to even manufacture. Here we compare our technique with state-of-the-art methods. In our first experiment, we focus on relighting with self-reenactment. Specifically, we divide the target's OL80 dataset into two subsets, training and testing. The test set contains the ground truth environment lighting emulated by the light stage. We use our technique to estimate the reflectance field and apply our relighting scheme. Compared with SOTA techniques, our approach produces better relighting results in both visual realism and actual errors. In our second experiment, we reenact the target performer using a video sequence of a source performer. Our technique is not only able to faithfully transfer facial expressions, but also preserve illuminations of the source environment at high photorealism. Thanks for watching.